So you can make a table and just plug in points on the respective interval. So like for this one, I'm just going to plug in values where x is less than or equal to -1. And then for this one, I'm going to plug in values between -4 and 2. And then for this one, I'm going to plug in values like greater than or equal to -2. Alright, so we'll color coordinate this. So like this table will make x -4, and then maybe -5 and -6, because those are values less than or equal to -4. So then like w of x or y, so it'd be the absolute value of -4, which is 4, divided by 2 is 2. And then the absolute value of -5, which is 5 divided by 2, would be 2.5. And then the absolute value of -6 would be 6 divided by 2 is 3. Alright, so now I'm just going to plot those points, -4, 2, -5, 2.5, and then -6, 3. Alright, and then boom, there's our graph. Now, if we were just graphing the absolute value of x over 2 for all x values, alright, then the entire graph would look something like this. It would look like your average absolute value function, but where the slope of these lines are 1/2 or -1/2. Alright, so pretty much we're just graphing that, but only over the interval where x is less than or equal to -4. Alright, so now that part of the graph is done. Alright, now we're going to do the same thing, but for this part of the piecewise function. So if I make a table here, alright, even though it's less than -4 and greater than, it's greater than -4 and less than 2, I'm still going to plug in those values, but I'm going to give it like an open circle when I graph. Alright, and then same thing for like, if I plug in 2, I'm going to make that an open circle. But if I plug in something like 1 or -1 or even 0, right? So those are, here are some friendly numbers that are on the interval between -4 and 2. Alright, those are going to get closed circles. Alright, so if I plug in -4, I get the square root of -4, which is just the square root of 4, which is 2. So I have the point -4, 2, which I said was an open circle, but since there's already a point there, it's going to be a closed circle, because if you plug -4 into this graph or that graph, you're going to get 2 either way. So the entire function, like w of -4, does equal 2. So we're going to have like a point there. So you don't have to do this like open circle and closed circle thing. You could just kind of start the graph from that blue point. Okay, and then we plug in -1. So it's the square root of -1, which is square root of 1, which is 1. So now we have the point -1, 1. So like what I mean is we're now just going to continue this graph from that point on. Alright, then if we plug in 0, we get the square root of 0, which is 0. So there's another point there. And then if we plug in 1, well, we get the square root of -1, which is I, and that's not a real number. So there's nowhere to plot that on our graph. So we're pretty much not going to like graph anything on this interval here. It's just going to kind of be undefined, because if you plug any x value on this interval, like where x is in between 0 and 2, and that's because the domain of this is -x has to be greater than or equal to 0, which means if you divide both sides by -1, x has to be less than or equal to 0. So really, like, we're only graphing it from -4 to 0, because anything greater than 0 is going to be not defined, not going to be a real number there. Alright, so then we finish our graph by graphing y equals the absolute value of x minus 2, where x is greater than or equal to 2. So if we made another table here, and we plugged in 2, 3, 4, we would get 0, 1, and 2. So now we have 2, 0, 3, 1, 4, 2, and that red, orange, and purple part all together, that would be our graph of wx. Alright, if we were to graph the purple part for all real numbers, like, it would look something like that. But since we're only doing it where x is greater than or equal to -2, we're going to leave that part out. And there's our graph.